Hi everybody, welcome to the video on the model building using Keras. I have imported NumPy, Pandas, Matplotlib, and Seaborn, and Tensorflow as a backend. The database I will use today is the portfolio diversity database, and which ranges between 0 and 1, 0 being the minimum diversity and 1 being the maximum diversity. And the purpose of this video is to predict the level of this diversity using these variables. So here I have firm level and top management team level characteristics, and in total 11 variables including this target variable, and 854 observations. I have split dataset into trained dataset and test dataset, and trained dataset has 80% of the observations, and test dataset has 20% of the observations. Train target is y variable of the train set, and the test target is the y variable of the test set. And these variables of course are portfolio diversity, as I mentioned before. Before I start any building, it's important that all variables have the same levels. For example, here MBA proportion, gender composition change between 0 and 1. They have smaller values, but for example, average age, count partners, and count patterns, they have large numbers. So, and it's quite difficult for gradient descent to optimize these numbers and find the best coefficients parameters. Therefore, I need to normalize my variables before I build any model. Here I have used a traditional normalization algorithm which uses mean and standard deviation. Here I have described descriptive statistics. So, and I have here count, mean, standard deviation, minimum, maximum of all variables, of all independent variables. And I subtract mean from trained dataset values and divide it by standard deviation to find normalized values for my trained dataset. And I apply same technique to my test set to find normalized test data. But the important thing here to mention is that I have used train stats, so mean and standard deviation of my train set to normalize my test set, because so doing I have the same distributions in two data sets, which is important for my accuracy in the end. So train data set here, as you can also see, now all variables have the same levels. They have small numbers now. Now we are ready to start building a Keras model. Here the Keras model, I have this structure. I have specified this structure. So 8 fully connected layers and one last layer which gives only one output. This is not a fully connected layer because this is the last layer for our output. And I have used optimizers, RMS prop. There are also other optimizers in Keras, so ADEM, ADEMAX, ADEMGrad, but I have used RMS prop because this gives the best results for my data. And I don't have any specified alpha learning rate, so I can specify it like this, but I prefer to keep it as default. I don't specify anything. And the loss function, there are also many different loss functions for regressions and for other types of models in Keras, but I have used MSE, so mean squared errors for my loss function. And for my metrics, I have used MSE and mean absolute errors. So here is the model summary, and there are 212,801 parameters to be trained. So this is huge. This is a huge model, and it takes some time to train this model. And here I have fitted the model using normalized train data and train target. So I have specified epochs is equal to 1000. So we have 1,000 different epochs to find the minimum loss function. And validation split is 0.2, which means that 20% of my train set goes to the validation set, and in the end I get the result also for the validation set. So loss of the validation set and metrics of the validation set. As you can also see from these results, loss and metrics of both train and validation sets are decreasing over time. And here is the graphic of my model improvement, and this solid line represents the train set loss function, and this dashed line represents the loss of the validation set. As you can also see from this graph, both values are decreasing over time in 1,000 epochs. Once you have everything, now we can predict using test data. So model hasn't seen the test data yet because we have trained the model using the train set, and now we give it the test set and see how it predicts using the test set. And then here are the results of the predictions. Of course, it's difficult to understand these predictions because we don't know anything. I mean, we don't know whether this is good or bad, and therefore it's important that I visualize these predictions versus the actual values to understand how good or bad the model is, the predicted model is. So here I have used this plot to see the distribution of my test targets, so actual values and the predicted values. And so I will plot this in the same axis and to understand how bad or good the model is. So here we can see that in this graph, the predicted values are quite close to actual values, which means that model is quite good, and so it's a little bit off around 0.4 and here 0.8, but overall model is quite good and is doing quite well in predicting the test data set. So thank you for watching this video and see you in the next video.